Okay, it's 1 o'clock Central Time. Welcome to our next episode of the HDF Clinic. And it's, as always, all about your questions around HDF5. And there's one open question that I still don't have an answer to, but I also checked earlier our shared Google document. I didn't see any questions there, but for those who signed in today, are there any questions at this point about HDF5, your applications involving HDF5 or anything HDF5? No? Okay, then we'll just go through our usual motions here. So yeah, the open question is still that I haven't gotten an answer to. I think 2 episodes ago, we talked about file locking and the changes that came to HDF 112.1. And the question is, will those changes be brought into 110.8? And I don't know, I'll find out sooner or later. So definitely one of the next meetings, I'll sure have an answer to that. Okay, let's go through last week's highlights. We have a few announcements out. Most importantly, we have a great event coming up tomorrow for 2 days, July 7th and 8th. It's the European Hug event, the HDF users group event hosted by ESRF, the European Synchrotron Research Facility. You can still register for it. It's completely free to register, to attend, and so forth. It's linked here. If you go to the forum, the program is available now. Of course, since the event takes place in Europe, it's sort of geared around what people in Europe might find convenient in terms of timing. And it starts, I believe, around 2 o'clock European time and Central European time, that is. And so that translates into 7 o'clock Central time here in the US. And so on the East Coast, that would be 8 o'clock, and then a little earlier in the other time zones here in America. But still, it might be a great way to enjoy a cup of coffee in the morning and tune into some interesting presentations. And but then, hey, if you have to miss it, then we have the Hug event here for the Americas coming up in October, and we are still open. The website is still open to submit papers and presentations. Deadline for abstracts is August 1st, so you still have another month roughly. And tomorrow's event is it's a fantastic program. I'm really looking forward to it, and this event here will also be very interesting, I'm sure. Another thing is we have now, we've worked for quite a bit of time on what started with the reference manual for HDF5 to put that into Doxygen, meaning that the documentation itself sits in the public header files in the HDF source code, and then we generate sort of static HTML mostly documentation from that, and that documentation now has an official home, and I put the link here, but again, it's available in the notes after this on GitHub. The official link is docs.hdfgroup.org/HDF5, and then there will be a few version specific, in the sense of supported release version specific sort of subdirectories, if you wish. So there will definitely be always the hottest develop based documentation, but then also for in this case version 1.12, version 1.10, and version 1.8, there will be versions of that documentation that are geared specifically to those releases, because going between these major releases there are sometimes API changes and so forth, and that requires adjusting the documentation, adjusting the examples here and there and so forth. But that's very exciting that now we have sort of a permanent home there. And this should also be pretty resilient in the sense that you will notice already when you go to the reference manual, the speed is just, it's much faster than the old version of documentation. And it's also, it's not hosted on a local web server. It's actually hosted just in an S3 bucket on Amazon. And so there's no server infrastructure from the HDF group involved in that. And so that should be really as efficient as can be. I'm going to pause here and ask if there are any questions, because this is really about your questions. I mean, I'm happy and excited to talk about HDF5 and the recent events, but this is really your time to ask questions, and I'd be happy to answer them as well as I can. Any questions? No? Okay, then I'll just continue. So those were announcements. On the forum, there were a few interesting, there are always interesting discussions, but I just picked the ones that I'm interested in. Again, we have this open thread still. This is for the HUG event in October, where we want to collect wishes for features or small changes where people say something would make a big difference in their HDF workflow if they only could do X. And so there is a thread on the forum where we are collecting these ideas. And again, it's your opportunity to chime in and say what you would like, and then we'll bundle them all up together in a sort of lightning talk type fashion and present them to the full HUG audience in October. Then there was another question here related to Swimmer and NFS, which is kind of sort of a, we've seen it several times already, and it keeps coming up, but the reason why it keeps coming up is probably because our documentation is not very clear, or it's not easy to find. The documentation itself is clear, it's just not easy to find, and it's not sort of highlighted or displayed as prominently as it should be. A user was reporting that they were using 110, I believe, 110.4 version of HDF5 and using Swimmer, the single writer, multiple reader feature, and it didn't work. And yeah, that's kind of expected in a sense that, and I linked, if you look at my response in the forum, I pointed to the places in the documentation that really make clear that with the current Swimmer implementation as it exists in HDF 110 and also 112 at the moment, that implementation depends on sort of POSIX write semantics, and in particular, part of POSIX write semantics is the preservation of write order, and file system, typically network share type file systems like NFS and Microsoft's sort of Windows shares and so forth. They do not guarantee in order writes, and or in some cases we also need atomic writes, and they don't do that. And yeah, so they can hence not support the current implementation of Swimmer. Now, having said that, there is change on the horizon, because I don't know what the release plans are, but maybe that's something to pick up in another of these events. There will be a re-implementation, a better implementation, if you wish, of Swimmer based on the VFD, the virtual file driver layer. And again, in my response on the forum, if you check, I linked the RFC where there is a section for the RFC for VFD Swimmer that talks about NFS and object stores and things like that. And so that implementation is in principle capable of dealing with these issues. It's no longer a requirement that you need the strict POSIX right semantics. So there is hope that, and I know there was some testing occurring behind the scenes already with the developers that tested also NFS and so forth. So change is coming. How soon? I don't know. I do not know which will be the first HDF release. Probably 112 something, 112.1 will be out pretty soon if it's not out already. So maybe 112.2 or 112.3, I don't know. But so change is coming, but again, long story short, the current swimmer implementation as it stands in 110 and 112 current version do not support NFS. And then there was another interesting post somebody asked about. They have sort of what, depending on where you are coming from, you might look at this as multiple channels or data frames or something like that. And the person was asking about how would you represent something like that in HDF5? And there are many ways, and it's many good ways, many straightforward ways to do that. And in my response, it really depends on if you want to use something off the shelf that's available, so to speak, in the ecosystem. And there are pretty good solutions available in the ecosystem, such as PyTables, Pandas, R data frames, but also Julia data frames and so forth. So if the scale of your application and maybe you have a default main environment, so it's not that you have to share your data with lots of other users, that some people use MATLAB, some people use C, some people use something completely different. So if you can live with the decisions that people made in Python or in R or in Julia about how to represent these things in HDF5, then definitely go with that. Only if you have these multi-environments, these multi-language environments, multi-tool environments, or the scale and the performance requirements for your data are such that you really want to take a closer look into this and come up with a custom design. But if that's not the case, go with something off the shelf. And the kind of queries I think that the user described they were looking for, that's all well covered with data frames in all these languages that support data frames out of the box. And so I think, but yeah, it's always good to ask and yeah, learn something new. I'm going to pause here and ask, are there any other questions related to HDF5, around HDF5? No? Okay. Then I've prepared something which I had to prepare anyway, but I thought it fits well here also, is HDF in a way is what it is because of a great ecosystem that exists around HDF5. So there are people out there, we mentioned already all these language bindings for other languages, Python, R, Julia, and so forth, C++. And people are doing and have done fantastic work to provide language bindings and wrappers and so forth in those languages. And another sort of angle, there are sort of, it caters to different languages, but then there are also a few language neutral, in a sense, approaches. And here's one called HDFQL that I think deserves to be highlighted in this. So if you haven't heard about it, definitely check it out, because yeah, for all these things that you might encounter in your HDF workflow and so forth, sure, you can go out and use your favorite language and just code up something, but it's always good to especially for prototyping and so forth, to quickly try something without writing a tremendous amount of code. And especially if you are coming sort of from maybe from a database background or sort of a query language based environment, then HDFQL is definitely worth taking a look. So yeah, HDFQL stands for Hierarchical Data Format Query Language, and it's a high-level language, but it's not sort of in terms of distinguishing imperative versus declarative language. It is a declarative language like SQL. So declarative really meaning you're not expressing what needs to happen, you are just expressing what you would like to retrieve or update or write in terms of data. So it's very convenient that way. And yeah, obviously SQL, the structured query language, is the gold standard in terms of simplicity and power in that domain. And yeah, people talk about NoSQL and so forth, but they've all sort of come around, and SQL is kind of the cornerstone for all of these NoSQL environments. And of course, if you are dealing with HDF5, there are certain adaptations necessary to really deal with things that are not present in the relational model, such as hierarchies and groups and links and compressions and attributes and so forth. So it needs to be adapted for that. And then you can also talk about, well, okay, so if I have now this abstract query-like language, how do I actually get stuff done in a real language? Do I just have sort of like a REPL, like a shell, and then I execute these SQL commands in that shell, and that's it? But let's say I want to write a Python script or a Java program or something like that. Do I have to then spawn external processes or something like that? Or on the other end of the spectrum, of course, people have come a long way with embedded SQL or language integrated query or link as sort of a very convenient way of bringing sort of query type constructs into the respective programming language itself. Well, here the author of HDFQL sort of steered sort of a middle ground, and what he chose to do was he basically treats HDFQL, this query language, as a guest language that is then embedded into a host language, and the currently supported host languages are C, C++, Java, Python, C#, Fortran, and R. And I'll show an example in a moment what this looks like. But basically, yeah, for your data needs, you express those in HDFQL, and then to sort of get this whole thing going, you can either use the shell if you just want to play around with a few queries. That's perfectly fine. He provides a shell for that, the typical REPL type environment. But when you're ready then to sort of put this to use in your application and so forth, then there are these embeddings here available for these host languages. And it also, I just threw that in here, it supports parallelism, for example, among many other things. I don't have a complete list of things that it supports, but in particular parallelism in the sense of multiple cores where possible, but also parallelism in the sense of MPI, should you want to use that. And so what I did here is I used Fortran as the host language. And here is an example of a Fortran program that where you see the strings in here, so to speak, are either messages printed to the user, or in the case of this show statement here, or this select statement down here, they are actually in some cases dynamically constructed HDFQL queries. And so in a typical HDFQL program really looks like this. You basically construct HDFQL query strings, and then you execute them. And basically the sort of the language embedding into a specific host language is really typically some kind of way of executing HDFQL queries. So here, for example, we are using this HDFQL module, and we are maintaining a return status for our statements, and then we just execute things. Like we tell HDFQL, for example, which HDF5 file we would like to use. So in this case, we are saying use file data.h5, and then we are, for example, listing all data sets that, and then typically in an HDF5 file, there will be multiple data sets, and then you can use sort of these wildcard, or also in SQL, these like expressions are very common, like with some kind of regular expression or pattern syntax. So here we are saying, well, basically find all the data sets that have temperature in their name, and the */ basically says at any level in the hierarchy, so not necessarily just in the root group, but sort of pretty much iterate over everything. And then the caret is basically the name of the data set should start with temperature. And then we further restrict the data type to float. And then, so that would create some kind of cursor where we would sort of batch these different names or path names of these data set, and then we are just echoing that to standard out in this case. And then we are sort of iterating over that cursor, and then we are basically, now that we have the name of that data set available, we can just select values from that, and then we can do things like ordering them in ascending order, and we can do a select into, so we can combine that with exporting that to an external file. In this case, it's called output.txt, and we are sort of putting every value on a new line. We could also combine them in blocks if we wanted to have multiple of them per line. And then in the end, we just close the file. And I just keep noticing here that I forgot to put the right kind of quotes in here, but that should be better now. And just to give you a few more examples of these without, so this is pretty much the pattern, what it looks like for any host language. So in this case, it's Fortran, but if you do this in R or in C or in Python or in C#, it looks pretty much exactly the same. You compose somehow, should that be necessary, an HDFQL query, and then you basically execute it. And then, of course, when you interact with the environment, like a buffer in memory into which you would like to fetch results, or from which you would like to draw data that you would like to insert into a data set, then there is syntax for that. But other than that, it's really all these programs follow sort of the same pattern, and it's actually pretty straightforward in my opinion. Now, a few more queries here just to give you a flavor of how deep this goes. So you can create new files. Here's an example. If you want to use MPI parallelism, for example, you would have multiple processes, and you remember that, yeah, certain operations when you do MPI parallelisms have to be collective. So this would be a way of doing that with MPI. You can create groups and, of course, attributes and things like that. But then you can do things also very compactly, like, for example, here, you can create a data set, you specify the dimensions, they can be also infinite, and you enable compression, like in this case, gzip compression via zlib. And then another interesting feature in HDFQL is, for example, the import-export from Excel files, if that's something of interest to you, definitely check it out. I think this is something that was introduced in the latest release of HDFQL, the import-export from and to Excel. And then, yeah, as I said earlier, you can interact with data that you have in memory and so forth. And then, yeah, there's wildcard type syntax where you can, for example, look at attributes that contain the digits 1 or 3 in this case for objects below this group called, this path name called group 2. So there is a whole lot. This is really just a sort of a quick snapshot of what HDFQL is capable of doing. I really recommend, especially, yeah, if this might look a lot more natural for users that are coming sort of from a little bit of a databasey background, and people often refer to HDF5 as a database, and that makes sense in a very broad, if you mean by database, data with a space between data and base, then that HDF5 certainly is a database in that sense. But then without something like HDFQL, you might say, well, where's that query language? Why do I have now to sit down and write C programs or something like that? I don't want to write C. I'd much rather have some kind of query language to make things happen. And HDFQL is a easy way to get started on this. Now, I included a few links here. First of all, yeah, the HDFQL homepage, where you can download binaries for Linux, Windows, and macOS. And the binaries really include the sort of, call it the shell or the REPL for HDFQL that you can use just to, with existing HDF5 files that you might have, or again, you can easily create HDF5 files from that shell and then create data sets and just play around with data sets, especially if you have a few Excel spreadsheets floating around, you can work with that. And Excel, for example, yeah, if you, it's not as simple, it's not just that you can work with one worksheet. There is a syntax, there is a whole syntax where you can refer to a specific worksheet in a particular Excel workbook and so forth. So it's really, this is just a bare bones example that I've listed here, but that's all included in these binaries. And what's also included are then these embeddings for the host languages that are supported. So the shared libraries for C, C++, and C# and Python module and Fortran module and so forth. There's also a great collection of examples available from the website, again, that covers all the supported host languages. So there is a nice tabbed display where you can see C, C++, C#, Java, R, Python, and so forth. And there are examples for each. And you might say, well, how is this licensed? Well, I recommend you you look at the license. What I can tell you is, number one, the HDFQL is available freely for commercial and non-commercial use. However, the license is not one of the standard BSD or Apache or MIT licenses. So there is a license and it's linked here. But if you go to the HDFQL homepage, you can see the terms, and that's what I think you should do if you want to, if you consider using it in your project, and then in a way making yourself dependent on HDFQL. And that's pretty much it, what I had here. Again, I think we should do this periodically, also highlight some of the great activities that are out there in the ecosystem. And that's one of the nice things about HDF5, that there is such an ecosystem. I mean, at the end of the day, HDF5 as the library is a very esoteric, low-level kind of affair. And you sometimes wonder, well, how is it so popular? Are people really that desperate? but it's the ecosystem. It's the volunteers out there, most of them, that write these language bindings, these tools, and so forth. And this is what makes HDF5 work, and for users to solve real problems. And I think that's the least we can do, is highlight some of these efforts at on occasions like this, but also if you come tomorrow's Hug event or in October, then you will see even more. And I think I'm going to leave it there. I thank you for coming. And yeah, let's come back here next week and see what has happened in the meantime. I'm sure we'll have an update on the Hug event for the next 2 days. And yeah, see you next week. Thank you for coming.